Everyone, and welcome to the first lesson of topic 4. Today we are going to talk about the relationship between rigid motions and congruence, and talking about congruence in general. So we've talked before about congruence in that when two figures are congruent, there is basically no change in size, no change in shape between the two figures. Essentially what's happening is we have a rigid motion that would map this figure from one onto the other. And again, we spent a lot of time last topic talking about our rigid motions. So sometimes you could call a rigid motion a congruence transformation because it's basically something that's going to keep your figure the same shape and size throughout the entire transformation. So that's another name for a rigid motion. Now, we have talked before again about the term congruent, and a lot of times we are using this symbol to show what congruence is. And if we are specifically talking about triangles that are congruent, you would say, okay, this triangle ABC is congruent to triangle DEF. Looks like we did a reflection over line M to preserve that, to show that that's how that would map onto the other. Sometimes we need more than one congruence transformation to prove this. For instance, if we want to try and prove ABC is going to be congruent to LKE, those two triangles, what we could say is, okay, well, I translated triangle ABC 3 units down, and then I reflected it over this line, this vertical line, through x equals -4, and that would prove that these are indeed two congruent triangles through those congruent transformations. Now, once we know that figures are congruent to each other, they have corresponding parts that then would also have the same size involved. So for instance, sides that are congruent or angles that are congruent, again, all of them should be in one triangle to another or a figure to another if they are truly congruent. And again, we show this through a congruent statement if something is truly congruent. So we have triangle ABC, so notice 1 tick mark, we have 2 tick marks here with C, 3 with B, and we have 1, 2, 3, again, all those angles being congruent in one to the other. So if we do 1 tick mark to 1 tick mark, that would be A to triangle. D would start. If I then go to 2 tick marks, I would say C, 2 tick marks, and my second one would be F. And then last B had 3 tick marks, so did angle E. So notice the order is super important here. That's something that we want to note. Order matters when you are naming these. So we know just from this congruent statement, even without a picture, I would know, for instance, that angle A and angle D are the congruent ones. Speaking of that, we can fill in this chart then down below. Angle A and angle D are congruent. Angle B is congruent to angle E. And then angle C is congruent to angle F. Now sides, notice again we have the tick marks marked in our given picture. A to B is going to have 2 tick marks. Well, that means it is congruent to D to E in the second part. That segment here again has 2 tick marks, or you could have said ED. And then we have BC, which is 1 tick mark here. That's the same as E to F on this one. And then A to C, 3 tick marks, we would have D to F in our second triangle. Now again, you could actually use the congruent statement to help you with that as well. So for instance, we had A, B, and D, E. Well, A, B were these two here that would have to correspond to D, E. Or we saw B, C here, that's E, F. Okay, so that's why the order is so important in your congruent statement, because it can help you, even without a picture, line up your corresponding sides and angles. All right, now on the back, we have an example here of our first triangle. Notice there's actually 2 triangles being divided up, and they are going to be congruent to each other. They marked all these sides and angles, except notice there's this side down the middle here that they share, Q to T. All right, we would call that a reflexive side, and we'd still mark that as our third side that's congruent. So we have 3 tick marks there. So notice there's the triangle 1 and triangle 2. So if we want to name our triangle congruent statement, okay, triangle 1, we could say QRT would be the first triangle. So we went from 1 tick mark to 2 tick mark to the right angle. So when we name the second triangle, we would have to say QST to make sure we keep that order correct. Now, as far as the segments that are congruent to each other, the 1 tick mark segment on the left was Q to R, and then the segment on the right would be Q to S. 2 and 2, we have r to t, and then that's the same thing as s to t. And again, we could also look here, r to t, s to t, those lined up. So we would say rt is congruent to st. And then finally, again, it's kind of weird, but they share this side in the middle here, qt. So we would say that qt is congruent to itself, qt. Because again, it's the same side of both triangles. Now, as far as the angles are concerned, now we have to be careful because notice if we say angle Q, there's officially 3 angle Qs. So we want to make sure we name these using 3 letters. So for instance, RQT, the first one, then we would have to say SQT, that one. The next one, if we want to talk about angle R and angle S, notice those are the only angles there. So you could say angle R and angle S. Or again, if we're going to keep with naming 3 letters, you could say QRT is congruent to angle QST on the other side. Or again, this is the only one you could officially say angle R is congruent to angle S because those are the only 2 angles at that vertex. Last but not least, we have the right angle, okay? And on this one, we have Q to T to R. Again, we have to have the T in the middle because it's the vertex. Q to T to S, so we know it's the other half, the other right angle. Q to T to S. Again, we can't call this one just angle T because there's too many angle T's at that vertex. All right, we have an example for you to try here. So first of all, you want to decide what is the triangle congruence statement for these 2 triangles. So triangle what is congruent to triangle what. And then you also want to label what sides are congruent to what. So you have XY, what's that congruent to? You have XZ, what's that congruent to? And then ZY, what's that congruent to in the second triangle? And then you have 3 angles, and again, we can name these with 1 since they are the only angles there. What would each of these be congruent to in the second? All right, now, sometimes they're telling us that the triangles are congruent. They give us the congruent statement. We then are in charge of marking the picture. So for instance, on the first one, they're telling us angle L and angle R are congruent. So I'm going to give each of those 1. Then they're telling me angle M and angle S are congruent. I'm going to mark that with 2. And then I have a third angle N to T. I'm going to give that 3. So now I have my picture marked with the angles. I also want to mark the sides. So if I'm between the 1 and 2 tick mark, L to M, I'm going to have to be between R and S, 1 and 2. 2 and 3, M and N, would be between 2 and 3 here. And then 1, 2, 3, last remaining side could get 3 as well, so I can keep those lined up. All right, your turn to mark this diagram. You are taking A, B, C and marking X, Y, Z. Try this one out on your own. All right, our final examples, right, today are going to involve a little bit of solving. So when we are solving for X with these triangle problems, first of all, notice they are giving us some information about triangle ABC and it being congruent to triangle DEF. So it doesn't really matter how you draw your triangle, but I'm going left, up, down. So when I mark it's congruent, when I want left, up, down, because I know, for instance, AB needs to be congruent to DE, BC and EF, AC and DF because of that congruent statement. Now they're telling me that A to B has a measure of 14, which means I know D to E also would be 14. B to C, they said, is 18. Well, I know E to F would also have to be 18. And then they told me C to A is 21. And D to F, this final piece right here, 2x plus 7, we know would have to equal 21. So this is actually the piece of info that's the most important to us, is that we need C to A and D to F, because if we want to solve for X, they gave us a little bit of extra info. Really, all I needed to know is that 2x plus 7 has to equal the 21. Now when I solve, I have 2x equals 14, divide by 2, my x value this time is 7. So you try the next example on your own. Again, you're using the congruent statement / draw yourself a picture to set up and solve for x. All right, our final example of the day is dealing not with the angle measures, the side lengths, but we were dealing with the angle measures. So again, just to visualize, I'm going to draw two triangles. Oops, this time we have J, K, L, and they're telling us that is congruent to D, E, F. And angle J this time is 37 degrees, which means angle D would also have to be 37 because they're congruent. Angle E is 64. Well, angle E and angle K are congruent. This also would have to be 64. And then last but not least, they're telling me that angle F is 3x plus 52. So a couple ways we can look at this problem. I'd say there's two options. Option one is if we subtract from 180 the two remaining angles that we have here, we can figure out what angle L, thus angle F is. So we can take 180 minus the 64 minus the 37, and I know that it's going to come out to be 79. So I can take, for option one, 3x plus 52 and set it equal to 79. Now this time I'm going to subtract the 52. I would get 27. And then when we divide by 3, x ends up equaling 90. Now option two, which also could work, let's say you didn't figure out what this missing measure was. Let's say you didn't find that that was 79, but you do know that, again, that these have to add up to equal 180. So you could also do that. You could take 64 plus 37 plus 3x plus 52, because we know all three of those angles need to add up to equal 180. So condense first, 64 plus 37 plus 52. You would have 3x plus 153. Subtract the 153 over. We get 3x equals 27. So either way you do it, you should get your x value to be 9. Okay, so two different options depending on that setup. Now I have a second example for you to try, but be careful on this one. They are giving you actually all three measures of triangle A, B, and C. They gave you all three of those measurements. You then need to think about in triangle D, E, F, if they give us the measure of E, what would be the value of x? You would set up and solve. Thanks everyone for watching, and we'll review more in class.